The recent discussion featuring Alexander Bush of Fox 32 Chicago and Avi Loeb sparked a wave of public interest, especially after NASA released its latest images of the interstellar object 3I/Atlas, prompting many viewers to express disappointment about the quality and clarity of the data presented. Avi Loeb responded by explaining in great depth why the public felt let down and why he believed the press conference was mishandled from the start. He emphasized that when NASA tells the public that something is interesting enough to be addressed by top officials, the public naturally expects to hear about the mysteries, not reassurances that everything is ordinary. Instead of highlighting the unknowns, the anomalies, and the puzzles that excite curiosity, the press conference focused on what NASA already believes 3I/Atlas to be, a familiar type of comet that just happened to come from a different environment. Loeb argued that this approach fails to capture what people care about most, the scientific adventure of exploring the unknown, identifying the gaps in our understanding, and showing how new data could help answer big questions. He stressed that public outreach should not diminish mystery, but should amplify it, making clear why the object deserves serious scientific scrutiny. According to him, NASA missed a major opportunity to engage the public honestly by acknowledging uncertainties and inviting them into the process of discovery. Loeb then pointed out that the second major mistake was holding the press conference at all, given the extremely limited amount of new information available. The images released were blurry and degraded, mostly showing vague shapes rather than meaningful detail, and he noted that the best image, taken by the high-rise camera aboard the Mars Reconnaissance Orbiter on October 2nd, had actually been withheld for 45 days during the government shutdown. This delay only inflated public expectations, making the eventual release feel anticlimactic. After examining the high-rise data with a colleague, Loeb concluded that the image contained no substantial new information, and the remaining images were even worse. The only subtle detail he could extract was that the glow or fuzz surrounding the object appeared elongated in the direction of its motion rather than pointing away from the sun, which is what scientists would expect from a typical comet shedding gas and dust under solar heating. For an ordinary comet, the tail generally extends along the line between the object and the sun because material pushed off the surface drifts away in that direction. But in this case, the glow stretched sideways, aligned with the path of motion, raising a puzzling question. Why would something appear to precede the object instead of trailing behind it? That unexpected orientation made the image intriguing in spite of its low quality. Yet NASA's presentation ignored this curiosity and instead tried to lower expectations further. Loeb argued that when the most interesting detail is a faint, puzzling glow ahead of the object and the officials do not address it at all, the public feels misled or talked down to. He explained that if 3I/Atlas were technological in nature rather than a natural comet, the forward glow could potentially indicate something entirely different, such as a beam of particles or light illuminating the path ahead to protect the craft from micrometeorites. At a speed of 67 kilometers per second relative to the sun, even a tiny grain of dust could cause severe damage to a technological probe. Advanced technology might use a beam to charge incoming particles and deflect them with magnetic fields, or employ some more advanced, yet unknown method to clear the path. This is not a claim that 3I/Atlas is artificial, Loeb clarified, but an example of the kinds of hypotheses scientists could test if they were actively searching for technosignatures instead of assuming from the start that the object is just a rock. He stressed that science progresses by considering a wide range of possibilities, not by narrowing focus prematurely. If the mindset is fixed on interpreting everything as natural, then any evidence of technology, no matter how faint, might be ignored or dismissed before it is even investigated. Loeb called this a self-fulfilling prophecy. You cannot find technological signatures unless you look for them, and you will not look for them if you begin by assuming technology is impossible. To illustrate how an open-minded approach can yield meaningful results, Loeb shared a striking example involving the famous 1977 WOW signal, an unexplained burst of radio energy detected decades ago. He discovered that this signal originated from a region of the sky within 9 degrees of the direction from which 3I/Atlas arrived. This coincidence prompted him to immediately contact radio astronomers and urge them to observe the object across radio frequencies. As a result, the Meerkat Radio Observatory in South Africa conducted observations on November 5, scanning frequencies between 0.9 and 1.6 GHz, the same range used by cell phones. Although Meerkat detected roughly 23,000 signals, all were attributed to human-made sources, leading researchers to place an upper limit on any artificial transmission from 3I/Atlas in that band. Essentially, if the object were transmitting at a power level comparable to a cell phone, Meerkat would have seen it, and they did not. This kind of investigation, Loeb said, is exactly what scientific curiosity should inspire. A proactive search for technosignatures instead of assuming none exist. Loeb also emphasized that the James Webb Space Telescope, with its extraordinary sensitivity, could detect heat being emitted from 3I/Atlas that cannot be explained by sunlight alone. If such excess heat were found, it could indicate an internal energy source, potentially even an engine. Observations like this represent real scientific inquiry, but only if scientists are willing to entertain possibilities rather than shut them down preemptively. He argued that NASA officials' reluctance to discuss unknowns and puzzles undermines public trust. People feel respected when scientists share uncertainties honestly and invite them to explore the unknown together, not when authorities stick to safe generalities that provide no new insight. Moreover, Loeb criticized the fact that only officials spoke at the press conference, rather than the researchers directly analyzing the data. Scientists who examined the Hubble and Webb telescope images could have offered valuable details and engaged the public with genuine scientific reasoning, but instead the event focused on broad, nonspecific statements. Loeb believes this approach does a disservice to public understanding. When scientific agencies speak vaguely or avoid discussing mysteries, people perceive it as withholding information, even when the truth is simply that the data is limited. Being open about uncertainty is more honest and ultimately more constructive. Loeb's broader message is that scientific exploration thrives when researchers are free to investigate unconventional ideas. Interstellar objects like 3I/Atlas and the earlier visitor Oumuamua offer rare opportunities to study material or possibly technology from beyond our solar system. If scientists assume from the outset that these objects are ordinary comets, they risk overlooking evidence that could advance our understanding of the cosmos. Loeb called for a more balanced, curiosity-driven approach, emphasizing that science should not fear challenging existing assumptions. The universe is vast, mysterious, and full of phenomena we do not yet understand. Public interest in these mysteries is not something to suppress, but something to embrace, as it fuels the very spirit of discovery that science depends on.